Hello, good morning, and welcome to FB Live. I'm Sai Vabre, Director of. Today we are coming up with our fourth webinar on a very important and very productive topic in the manufacturing industry. Yes, I'm talking about Industry 4.0. Before go to the webinar, I would like to introduce you about our venture Tech Wisdom Forum. Friends, as you know, there are millions of MSMEs units spread all over the country who are contributing to the GDP and give a value addition in the manufacturing sector. To upgrade their skill levels and to improve their efficiency, we should impart a necessary knowledge and information in the to them in the language which they understand best. And yes, that is in their mother tongue. Student story is also not different because they can learn the basic concepts and easily if they can be presented in the language which they understand, or they can be taught in the language which they understand. And yes, exactly, we have identified the need and have come up with the solution, Tech Wisdom Forum. Tech Wisdom Forum is a Section 8 company, no profit, no loss basis, which formed to build the knowledge platform for mechanical engineering fraternity. This will cater to all needs of getting knowledge and information in Indian language. Basically, Tech Wisdom Forum provides a technical content in text as well as audio-visual formats in 6 languages, mainly Marathi, Hindi, Kannada, Gujarati, Tamil, and of course English. All the content we are bringing on a digital platform by way of a web portal named yantrikividya.com. On this web portal, you will find the training videos, expert talks, write-ups about the technical developments, and so many things. And all this content, all this information will be available to you in the 6 languages, as I have told you earlier. For students of mechanical engineering, we are giving a write-ups which are relevant to their syllabus. The very basic concepts we are giving to the on web portal, and of course they are in the language which they understand. I request to all of you, please do us visit our web portal, www.yantrikividya.com. Now I would request to our another director, Mr. Deepak Devdar, to introduce the subject and our guest. Thank you so much.
Hello, very good morning to all of you. It's my pleasure to introduce this subject to you and also the learned speaker. As we all know, for last 3, 4, 5 years, there is a buzzword in the industry for basically for the automation, the improving the overall effectiveness of the company. And it's a kind of a current fourth revolution in the industry, it is said, and it is a industry 4.0. It is always the apprehension that we had that in industry 4.0 is a ball game of a big companies. We need high-end machines, software, high-end computers to manage and organize everything for industry 4 per se. And so that the major sector of MSME typically kept themselves away from that, or they are little hesitant to go for it in a big way. And exactly we wanted to hit this particular mindset in today's webinar, that it's not so as it being thought in the market about industry 4.0. It is the tool for us to take on the Samruddhi Marg, which is a buzzword in typically in Maharashtra now, in Nagpur, Mumbai. Samruddhi Marg is just open partly, and the kind of the thinking behind this kind of big roads is a highway. It's a mega way for improvement for MSMEs industry 4.0. And to explain this concept, we have a eminent speaker with us from Bangalore, Mr. Dasarathi. He is a mechanical engineer and from NIT Surat, and MTech from IIT Kharagpur. He started his company's career around 30 years back, mainly from CNC machining and those kind of developing software for manufacturing. He started his company Cadem, and then now he is director of application for a company called LEANworks, who is effectively working and supporting the MSMEs to build a structure for Industry 4.0 in their organizations. So I would request Mr. Dasarathi to take over and continue his sharing about Industry 4.0 to us. Welcome, sir.
Thank you. Good morning to all of you. Thank you for taking time off on a Sunday morning to come and listen to me. I'll just share my screen. Right. So whatever size of company we are, when we start off, we have a vision for our growth, right? We want to be, let us say, we want to start off with a particular size of number of machines, and this is what we want to make. And after so many years, we want to reach this particular level of revenue and profits and so on. So that's this vision. But it's actually a very difficult thing to achieve that vision, considering how many variables are involved in running a shop floor, running a company, a manufacturing company. Industry 4.0 it's not just merely, it's been a buzzword, nobody understands it, there's a lot of confusion about it, people think it's very expensive, it's very high tech and all that. So actually the reality is that it's just a very simple thing, and it's very cost effective, very rapidly achievable, deployable, and it can help in a huge way in the manufacturing industry. So here's the shocking truth about most shop floors, right? Whatever size of shop floor you are, whether you have just 2 machines or 5 machines or 200 machines, the reality in a lot of shop floors which are not doing mass production is that the machines are down 40 to 50% of the time, right? And I'm sure you agree with this. So what does 40% actually mean? I love to use this example of a banana. So I buy a banana, and in that banana, I'm supposed to eat the whole banana, but I'm actually eating only 60% of the banana. 40% I'm deliberately cutting and throwing away. That is what 40% downtime means. I'm not using 100% of my capacity, 100% of my banana. I'm only using 60% of my capacity. So I'm sure you all agree with this number. Anybody who's doing small batch production, maybe you're changing the setups on your machine, whatever machine it could be a CNC machine, conventional, whatever it is. If you have multiple setups, maybe even one setup a day or something like that, this is the kind of number that we're actually looking at, right? And why is this happening? Because decision making requires data, and we don't have data. Decision making requires data and it's got 2 characteristics. One is it should be correct, and 2, it should be in time for me to take action immediately. But what typically happens on shop floors is that the data is wrong. It is deliberately cooked up and so on, or we collect it, let's say at the end of every shift, we collect the data, by which time you're actually depending on people's memory. Oh, what happened at 10 a.m.? What is this downtime of 45 minutes? Why was it? And things like that. You ask, and who's going to remember at 2 p.m.? Who's going to remember what happened at 10 o'clock, right? Everybody is busy doing their work. So this data is wrong and too late. Today's data, let's say there's a machine breakdown now, and I'm not available to attend to it. I come to know about it tomorrow morning, which is absolutely too late. When I could have taken immediate action and reduced the downtime due to the machine breakdown, I'm not available. So wrong measurements is equal to wrong decisions. and wrong decisions mean poor profits. That's what actually we end up with, right? And what are the typical problems? These problems, again, they're common to whether it's MSME or a large corporate. Most of them are common, except problem number one. Problem number one is peculiar to MSME, right? I'm running my shop, but I can't be in the shop 24 hours. I have to go out frequently. Maybe I'm in the shop only 2-3 hours in a day. The other time I have to meet customers, vendors, go to the bank, all sorts of things. So I need to be out. And when I'm out, productivity is low. When I'm in the shop, productivity is very high. Everybody is working, sincerely and so on. And then downtime at shift changes. Maybe my shift starts at 6 a.m., but my machine is only starting at 6:30, 6:45. Shift stops at 2 p.m. or 6 p.m. based on whether you have an 8-hour shift or a 12-hour shift. And half an hour, 45 minutes before the shift stopped, the machine is stopped. The operator, washed his hand, he's out. Right? Night shift, a lot of places, people actually sleep 3-4 hours, they just sleep, right? And then the next morning, you'll get the machine, there was a breakdown, but afterwards, after 3 hours, I tried to start it, it worked. All these reasons will come. And your operator turnover is very high. Every three months, 4 months, 6 months, the operator keeps leaving, and then you get somebody else. You take 1 month to train the new operator. Soon after he's trained, again, the new operator is left, right? So all these are your problems. I'm sure you agree with all these. All of these will be your problems. And if you're in a big company, then problem number 2 to 6 are your problems also. What's the solution to this? The good news is that I have personally seen, we've been doing this for the past 4 years. We've been deeply involved in implementing Industry 4.0 in various companies of various sizes, right from 2 machines all the way up to a few hundred machines, 800, 900 machines, large companies, corporates, and so on. And the problems are more or less common everywhere. The downtime can actually drop. Typically we have seen downtimes of even up to 50% when we install the Industry 4.0 system. And then it can actually drop to 20% in really rapid time of just 3 months. It's really, really rapid. That's what happens with Industry 4. But how does this actually happen? To 40% downtime to 20% downtime means instead of your 10 machines, let's say if you have 10 machines, 10 machines are doing the job of 6 machines only. Instead of 6 machines, 20% means they're doing the job of 8 machines. That's a huge jump, right? So how does that actually work? How does this happen? So here are the benefits that companies doing Industry 4, who have implemented Industry 4 typically see. The downtime reduction. Let's say 50, if you have a working day of 22 hours on a machine, so 22 hours, 50% basically means 11 hours. That 11 hours, the machine was down earlier, that has reduced by 70% in just 3 or 4 months. And then some companies who I've actually personally seen, they just stopped working in the third shift because the productivity in the first and second shift has gone up so high. Third shift, they simply stop working. And you can imagine the benefits of not working in one whole shift in third shift. You don't have all your canteen facilities, your power bill is reduced, the number of people, the number of machines, everything is reduced. All your support staff, everything has gone down drastically. You save enormous amount of money. And then reduce breakdowns, then reduce consumption of inserts and furnace gases, power, all these. Couple of companies have actually stopped buying new machines for them, even though their order booking is going up, orders are going up by 10%, 15% every year. They just stopped buying any new machines for 2 years. That's huge, right? It's a massive benefit. And why are they stopping buying new machines? Because whatever extra capacity, the excess capacity or extra capacity they want with the new machines, they're achieving by reducing the downtime on their current machines, using the current machines more efficiently. Right? And one very important thing is improved operator retention. All of us have this problem of, having problems with operators. People come, they leave very early, they're undertrained, motivation level is low, a whole lot of problems. So I'm sure all of us would like to see every one of these benefits, all the 8 benefits, and anything, all the other unmentioned benefits, the smaller ones that are not mentioned here. So how do we actually do this? How do we get these benefits and eliminate those problems that we have? The simple solution is get accurate, timely data. Today, you cannot take proper decisions because you don't have proper data on time. Proper data on time. These 2 things. That's it. All we need is this. And how do we do this? We just talk to the machines directly, make them part of our team. All of us have teams, right? But we have human teams. But who's making the money here? We're not making the money. All the human team is meant for running the machine, and the machine is making the money for us. Correct? Of course, we are operating it and so on, but the machine is actually making the money, and we don't talk to it. We talk to a whole lot of humans who are actually involved with the machine, and then get the data from them. Simple solution: talk to the machines directly. So how do you talk to the machine? Here's your machine. It could be anything at all. Literally, just imagine any process, any machine. Don't think CNC, robot, PLC based. It can be any manual machine. It could be conventional machines, anything at all. You can talk to literally any machine, right? With Industry 4. All you have is, let's forget about what these are. They just sound big. The names sound big, but they're actually simple, old technology. So you have an IoT sensor which is talking to the machine, finding out how many parts are made, when is the machine idle, when is it broken down, or when is it running. So all this it keeps tracking. Any rejections, all these can be tracked. It sends it to something called cloud software. Cloud software is nothing but it's just software on some computer somewhere, right? Now, like, we're sitting in front of all of our devices are computers. Even the mobile phone is a computer, right? So, but when you talk of Netflix or Amazon Prime or your bank account or a whole lot of things, all your online purchases through Amazon or your Flipkart and so on, that is all cloud software. It is some software sitting somewhere in some computer somewhere. You don't even know where it is. You don't care where it is. As long as you are sitting here and it is doing your work, that software is doing your work wherever you are. That is cloud software. It's the same thing here. Imagine that this is some Netflix or your bank account software. I mean, bank software. And so this cloud software is taking the data and from the machine via the sensor, and then reporting it. Then it does a whole lot of analysis and so on, converts that machine data into a form that humans can understand, that you can understand as a decision maker. And then it shows you various reports and various alerts on the web, on various devices, or on your mobile phone as alerts, right? So you can see all this data on your mobile, on your tablet, on your laptop, desktop, whatever. There are no humans in the data chain. That is the most important thing. Right? It's all completely automatic. But it is nothing to be scared of. I mean, there's so much confusion and fear, right, about Industry 4. It's some high-tech thing. It's very expensive. It's just there's nothing high-tech about it. There is just the same old technology, right? What do we have here? The same chain repeated here. You got the machine. Machines have been around like hundreds of years, not 500, maybe thousands of years also. The day the first wheel was invented, that's probably when the machine started. That's literally thousands of years ago. And the IoT sensors have been around 50, 60 years. Even the thermometer that we put in our mouth to measure the temperature. That's just basically it's a temperature sensor. If I connect that to the cloud, it'll start sending data about my temperature to the cloud. It's as simple as that. We're using sensors all the time in various of our, even our mobile phone has sensors and so on. Then the cloud software, we already saw it's just your Netflix or bank account, right? It's been around 10 years. And reports on web and mobile alerts and so on. All these also, let's say 10 to 20 years from when all these devices actually were invented. So what is it that is new here? There's nothing. It's all, a decade or more old. The only thing new is that we are talking to the machine and from a computer and getting data onto the computer. That is all that is new. There's nothing else new. Everything else is old technology that we've already been using for a long time. So there's nothing high tech about this at all. It's just a technology of talking, not even a technology. It is just using existing technology to talk to your machine directly and getting data from it. And so then what can you do with this data, right? Since there are no humans involved here, then there is no need for any of the devices there to sleep and so on. So this data is available to you 24/7. It's no holidays, no breaks, nothing. One, you can see reports of all your production, hourly production, shift-wise production, and details of individual cycles and so on, and rejections, rework, all these details you get. Then you can see alerts on your mobile phone, something going wrong, seriously wrong that requires your attention, immediate attention, like machine breakdown, or the shift is over but the target has not been met, or your rejections are very high. All these things which require your immediate attention, you can get alerts on your mobile phone wherever you are. So you've gone to your bank, you've gone to maybe some electricity board office to increase your whatever the power available to you. All this, you're sitting there and you get this alert, you immediately call your factory and say, what's going on? Which machine is broken down? What can I do about it? Are you guys able to fix it in time? If you can't, just tell me. I'll call our maintenance guy. So you can take immediate action. If you don't have this mobile alert, what are you going to do? The machine is going to be sitting idle there for 2 or 3 hours, and then you go back there after 3 hours, and then the guys tell you, oh, the machine not been working, sorry, and then you start taking action. So from then on, it's another 1 or 2 hours, right? So you can take immediate action, and also so you can act upon all this data to basically increase your revenue and profits. And what do you do with this revenue and profits? You're going to pay yourself more, obviously. Plus, you can retain your operators, right? You pay them a little bit out of this, the increased revenue and profits. Pay them better salaries and incentives based on their actual performance. So you get to retain good people. And then, so when we say connect the machine, how do you actually connect the machine? You have a device like this, which is actually an IoT sensor, and that has electronic inputs, right? Digital inputs, which you connect to the electronics of your machine. This again sounds very, high tech, connecting and sensor and all that, but actually very low tech. Anybody with very basic electronic knowledge can actually, or electrical knowledge can actually connect the machine. And I've deliberately used a machine here that is an electromechanical machine that has no electronics at all, right? It's a very old machine. So you can even connect all these kind of machines. And even if it's such a machine, then you can put in these sensors. You've seen all these, right? The inductive sensor or photoelectric sensor, some switches. You put these things cost like 1,000, 2,000 rupees, very cheap. 1/10 of the cost of your, the mobile phone that you're using, probably. So very cheap. So you can actually connect your machine, and from here the data will go straight to the cloud. There's no wiring, no nothing. What kind of machines and processes can we connect? Literally anything. So if it's a CNC machine or a robot or a PLC based machine or an automatic run by CNC, whatever, or any manual machine, you'll see a whole lot of manual machines here, right? You got a little furnace, you got your forging press, you've got the mold making machine from a foundry, you got another press. So all these machines, these don't have any electronics. These are just electrical machines. But you can connect these also. And how much? So this is how you connect. Connection is very easy, right? What the cost and the time? The most important thing. We're all waiting for this. How much does it actually cost? So the time to deploy this, the time to connect your machine is actually something like 15 to 30 minutes. Like even if, let's say if it's a CNC machine, what do you need to connect to the machine? Just a cycle start, cycle end signal, maybe spindle start, stop, right? Just maybe 2 to 4 signals from the CNC machine, from its relays. The vast majority of CNC machines will have relays. The latest new machines may just have an Ethernet port, in which case you'll have to connect it to the Ethernet cable and so on. But literally, it is just 15 to 30 minutes, half an hour max to connect. And the moment you connect the machine, you're up and running. You can start seeing your data on your mobile phone immediately. And or mobile phone or laptop or whatever it is. How much is the cost? The cost of the hardware is about 15,000 rupees one time, which 15,000, that's big. 15,000 is as much as your mobile phone, which we all like to change mobile phones like literally every year or two, even though they're working beautifully. So that's all it costs. And the software, you can either pay, it depends on who's there are a lot of vendors of Industry 4.0 systems. So the hardware cost may vary a little bit here and there, but broadly, this is what it'll be. Software, you can pay one time or you can pay monthly. And at the lowest end, just for collecting your software, again, you have a lot of higher end options also. But at the lower end, just production, productivity, your the downtime, OE, and so on, and your mobile alerts, it'll be about 1,700 rupees a month. What is the return on investment? Let's look at, these are big, 1,700 rupees per month. That's big. 15,000, that's big, right? Now let's see, is it really big? What is so I've taken a machine which costs about 250 rupees per hour, right? Let's say that could be something like a CNC lathe with a 200 chuck size, 8-inch chuck. So about 200, 250 rupees an hour, right? And if you, this will of course vary. If you have a horizontal machining center which costs 1 crore, 2 crore rupees, this is going to be, multiplied that many times the benefit. But let's say I have a downtime today of 40%. If I reduce it to 20%, what happens? My saving is, if I say 22 hours per day, I'm working into 26 days per month, correct? 4 days holidays, chutti. 22 into 26 into 250 rupees. That is something like 1.4 lakhs. That should be your theoretical earning per month. Now, let's say 20% of that I save. Earlier, I was, for 40% of that time, the machine was idle. Now I've reduced that 40% to 20%. So I'm actually saving almost 29,000 rupees, 28,600 rupees per month. And this is my additional earning per month, right? What I was earning till yesterday was something. Today, after putting in the Industry 4.0 system, not today, let's say in 3 months' time, when I reduce to 20%, this is what you're going to be earning additionally per month from that one machine. Some of it I put in my pocket as the owner. Some of it I give to my employees to make them more happy. Some of it I keep aside for, future growth, buying more new machines, things like that, for marketing, right? But this is your return, right? And What is the cost of the Industry 4 system? 2,200 rupees per month. Literally less than 1/10 of this. Your saving is 28,600. Your cost is 2,200 per month, right? And how is this coming? We said that 1,700 per month is your software cost, and then the hardware is 15,000 one time. So that one time I reduce it to, I'm paying, let's say, 500 per month. I amortize that over the next 2-3 years, which may be the life of the hardware. See, actually, this is the real return on investment from Industry 4.0. It doesn't matter what size you are. It could be just one machine or two machines, or it could be 200 machines as a company. And whatever the machine, if this is the kind of downtime you have, then this is the kind of return you're going to get, right? And there is no disputing this. Unless I start disputing, no, this is my downtime is not 40%, it is only 30%. Fine, even if it's 30%, then from 30% you're reducing to whatever. And how difficult is this to achieve? Right? It's just 3 simple steps. Just 3 steps. One, I plucked like all mango, like when I'm plucking mango from a mango tree, I pluck the low-hanging fruit first. Correct? My low-hanging fruit is the work ethics issue, the downtime at shift change. It could also include the downtimes. Let's say lunch break is half an hour, it becomes 45 minutes, 1 hour, all these things. But let's start with this. This is, let's say, out of a 22-hour day, 22 as in 24 hours minus I've taken off 2 hours, or it could be even 21 hours. Let's say you've got a three shifts of 8 hours each. You got a break of 1 hour in each shift or something like that. But typically, let's say if your total working day is 22 hours out of 24 hours, 2 hours out of that 22 hours just go in downtime and shift change. This is common. It's very, very common across all shop floors, across India and across the world, right? It's nothing specific to us. I mean, we don't, and a lot of people feel ashamed. No, yeah, it can't be this high. For me, it's not so. It is that high, unfortunately. That's what we found, right? Over 4 years of installing our Industry 4 system across various companies, thousands of machines, this is what we found. And so 10%, if I reduce this 10, eliminate this 10% and make it 0 or almost 0, then I'm actually saving 14,300 rupees per month. That is half of, earlier it said 28,600, right? So 14,300. So 14,000 rupees I save a month. If in fact this number 12% is, if I'm losing 1 hour in an 8-hour shift, it is straight away 12%. Step 2. So step 1, the low hanging fruit was the downtime and shift change. Step 2, the higher hanging fruit are all these 5. The top 5 reasons for your machine downtime, right? These are your top 5 reasons. Machine breakdown, setup change, inspection, no raw material, tool change. In most metal working industry, metal cutting, metal forming, it could even be for whatever, welding and so on. Anything to do with metalworking, typically these are the things. These are your top 5 downtimes, right? And this, if this is another 10, if I can cut off another 10% here in the same 3 months, then you've got your 20%. And this happens, this is very, very commonly done. It's not at all something that is impossible to do. It is very, very easy to do in the first 3 to 4 months. And then that was step 1, low hanging fruit. Step 2 is your top 5 downtimes. Step 3, 4, 5, you can keep on going like that. And these are, these don't, these yield you, they cost a little bit of money, and they may not yield you that big returns in terms of reduction of downtime and efficient and improvement of efficiency, but they all give you a lot, like 1% here, 2% there. Totally, you can, probably over the next 9 months or whatever, you can further reduce and improve the productivity, reduce your rejections, reduce the machine breakdowns, put in and eliminate. You can actually completely eliminate. Why should you have machine breakdown? Right? If you have proper preventive maintenance and autonomous maintenance, autonomous means done by the operator. Every morning, operator comes, he checks everything is okay, and then he starts the machine. And then maybe at the end of the shift, he cleans the machine, does a further set of checks. Right? You spend just 10 minutes in a shift doing this, and you got huge returns. And the Industry 4 system can actually enable you to do all this. It can enable you to implement autonomous maintenance, preventive maintenance, and so on. And as you grow bigger, today you've got maybe, whatever, 2 machines, 5 machines, and tomorrow, every year you're adding machines. So after 2 or 3 years, then you put in an ERP system and put in a proper maintenance schedule. All these, as you grow, you can further cut down all your waste, right? So the whole purpose of lean is to eliminate waste and improve your productivity. So what you're doing by reducing downtime, reducing rejections, rework, all this is reducing waste. So this is an endless journey. You can keep on doing it. And what do you mean by data? When I say data comes to humans to take decisions, what does the data actually look like? So you get reports like this. This report, for example, is just an hourly production report. Hour 1, hour 2, hour 3, and so on. How many parts were made? And here, for example, this report shows you the night shift. So this is a long part, some 45 minutes to an hour at the cycle time. In the night, you can see that the second half of the night shift, it is 0, 0, 0. What does this mean? Operator just popped off to sleep. Second half of the night shift, right? And then you have on the mobile phone, you can get alerts like this. The downtime is very high. It's supposed to be normal allotted inspection time is 10 minutes, but it's exceeded 10 minutes. Your setup time is supposed to be 1 hour maximum. It's gone beyond 1 hour. A machine breakdown. All these it can show you on a mobile phone. And then this is the downtime analysis. What was your downtime? What's your downtime trend week on week or month on month? And where is your downtime going? Which is your highest downtime? Which should you attack first? So a lot of reports like this you can get. I just show you a brief demonstration of an actual system, Industry 4 system. How does it actually look like? This you can see it's a web browser. This is my Mozilla Firefox, and you entered a URL there, and you enter the customer ID. And if you have this is for a multi-plant operation. And I just enter my username, password, and it takes me into the software, which you can see this on your laptop, you can see this on your tablet, on the mobile phone. There are apps there's an app which will show you all these. So this is your dashboard. It shows you what each machine is doing. Green means running. This orange or yellow means it is idle, and red means it's either it's broken down or ignoring cycles for whatever reason. Right? You can see a lot of these machines are running, some machines are idle. And this is the dashboard. So from the morning, from the beginning of the shift, how much is the available time, how much time was utilized, how much is the availability, then what is your planned production, how many parts were actually produced and what is the performance. So all these numbers you can see. And then if you want detailed reports of, this is for the, what was shown there is for the current shift. But if I want detailed reports for, let's say, the past, what happened yesterday, for example, let's say the downtime analysis for the previous day. I just select previous day here, and then I go and select the machine. And it shows me the downtime analysis for the previous day. So this shows me in tabular form how many hours out of the total 24 hours in the previous day, what are the downtimes like and where they went. This is the downtime Pareto, right? Here it shows that the setup was the highest, then new part development, then inspection time. So your top 3 downtimes are these, you can focus on them. Same thing as a pie chart. And then you can see your hourly parts production. Let's say hour-wise production for yesterday. So what part was running? And then it can also show who was the operator and so on. What is the operation number, part name, part number? What is the hourly target and how much was actually produced? Planned quantity for the first shift was this much, right? And actual quantity was this much. So utilization is so much. So you get all these reports. So these are just some of the reports. So productivity, OE, downtime, and then in production, your cycle details, and if you're a tool room or an aerospace company, then what is the spindle runtime? You're not so bothered about if your cycle times are very long, like 20 hours or 10 hours and so on. You're not bothered about how many parts you produce, but how much time did your spindle run? That is what you're more interested in. And then you can see trends of your revenue, how has been your downtime, spindle percentage, OE, revenue loss, rejection, quality reports, maintenance reports, right? MTTR, MTTA, all these, are they going up, down? Consumables usage, your power consumption, the inserts, coolant also very expensive, right? So all these you can see the consumption and so on. And so this is a lot of these. I mean, as you grow, you maybe initially you're not looking at everything, but as you grow, you're looking at more and more and more reports and trying to achieve more and more productivity benefits. Right? So this is what we mean by this ladder. Means that initially you start off small. Just look at your low-hanging fruit, the downtime at shift change. Then you look at other downtime. Then you look at rejection. Then you look at rework. Then you look at the maintenance, reduce your breakdown, things like that. Reduce your setup times. So what we saw in the past 45 minutes is that you started your firm with a vision of growth, and that growth is sometimes easy to achieve, sometimes usually is very difficult to achieve. We find that there are a lot of problems, labor problems, we've got raw material problems, productivity is so poor. When I can do something with 6 machines, and I have 10 machines to do it, which means I'm paying more every month to the bank for the interest and the towards the capital cost of the machine, all these things, right? It's happening because of poor productivity. And poor productivity is because you don't have enough data to act upon it. Industry 4.0 is not a magic tool. It is a magic tool to give you data. It is not a magic tool that can automatically improve productivity, but it's giving you data when you want it, and it's giving you accurate data. So with this data, you can actually take action. That is the beauty of Industry 4.0. And what we saw is that one, it is very affordable. It gives you huge return on investment. So you don't have to bother about its cost at all. It can be implemented in hours, in a few hours or a few minutes. It does not take you weeks or months, right? And it's nothing high tech about it. You can understand it. You can start using it very easily, and you can achieve very rapid returns from it in a few months. Yeah, and of course, in IMTEX, if you're going to be in IMTEX in Bangalore, it has this year, that is January 19 to 15, it has a big presence of Industry 4.0 companies. There's because it's a big thing today, Industry 4. There is a big hall for it also. So please visit that. Thank you for listening, and let's see if I have any questions. Yeah, if you have any questions or comments, please put them in Facebook. Anything you agree with, disagree with. So Mr. Ramesh Shahir has asked, how do you manage multiple machine concepts for this? So whether it's one machine or multiple machines, you connect them all to the same cloud software. Like a bank has, banking software actually caters to a whole lot of account holders. Like that, the Industry 4 software will cater to a whole lot of machines, and it'll show you, like I showed you now in the live demo, all those machines appear in the single screen. All your reports and so on will actually have multiple machines. I hope that answered the question. So Mr. Sanjay Kharat wants to know, what should be the first step when migrating into Industry 4.0? First step would be to put down what you want. What do you want out of Industry 4.0? Some people, so let's say it depends on your biggest pain point. My biggest pain point could be high rejections. It is not high downtime. Maybe my machines are all, it's mass production. It is highly automated, but I've got a rejection rate of 5% or whatever, which I want to reduce to less than 1%. And it's costing me a lot of money. So put down your pain points first. And then when you talk to the Industry 4.0 vendor, you tell them that these are my pain points. This is what I want to attack. And this is what I attack first. After that, this is my point. So put down your, maybe 5 pain points. What are the pain points and what are the medicines that you want? These are my pains, and this is the medicine I want. So when you speak to the vendor, please put down your pain points. Be very clear with them first. Somebody else may say, no, downtime is my most horrible thing. And rejections are not a problem at all. Downtime is my biggest pain point. So I want a system that tracks downtime. So that would be your first step. And then from there you go on. Speak to multiple vendors, find out who's got something that fits what you want. And of course, next would be you put on a budget and see and find out also what is your timeline. When do you want this fixed? Do I want my solution, let's say my rejection of 5% has to reduce to 1%, and that reduction is in your hand, right? What you can only get is the data. You're not going to, the Industry 4 system is not going to come and by magic, fix the whole rejection problem. You will get a data, but from that data, you'll need to take technical steps to fix that problem. Then how how is the data entry done? You've shown only a small sensor attachment to the machine. Do we have machine to machine talking option available? That is Mr. Devdar. So the data entry is done by multiple means. You can have, let me just see if I have some pictures.
Because this, I got one more, angle to this question.
Hmm.
That we said there is no manual intervention in data collection.
Right.
But ultimately, the reasons for the
Correct.
breakdown or whatever are entered by the people only. So,
Correct.
is there any mechanism to avoid that? And we have direct data capturing on the system. That's what my
Yeah.
real
So
point is.
now I have simplified that. I had simplified that picture to just show you that your parts production and the total downtime duration is 100% automatic. It is 100% automatic. How many parts are produced, how long the machine is idle, how long it's running, that is fully, there is no human intervention required. It is fully automatic. But why was the machine idle? That requires human intervention. Like if it's inspection or setup. So then the simplest way would be, you could have a set of buttons like this. And so these are illuminated switches. Let's say setup, rejection. One of this red button is rejection. Each time a part is rejected, press that button. Or this could be setup. This is breakdown. This is setup. Then inspection. No raw material. So you could have all the multiple reasons that you have. Operator just presses these buttons and it goes into your IoT hardware that sends it to the cloud. So the reasons go this way. This is a lower end. At the higher end, you could have it on a tablet. You could have a software thing. Then we have a mobile app also. Operator can actually enter the downtime reasons in the mobile app. Today, everybody has a mobile app. So some of the companies that are, some of our users actually, provide the shop floor Wi-Fi to the operators just to enter this. Okay. Only for downtime reason and rejection entry and so. So some aerospace companies where they want to have a full paperless office, they actually have a PC next to each machine because the machine there is very expensive. The machine may be costing 1.5 to 2 crores. So each machine has a PC. Operator looks at the drawings and various drawings and all your PPAP documents, your process sheet, your inspection sheets, all that he looks at in the PC. So there are a variety of operator interfaces, but this is our, it's most commonly used in wherever there's like auto parts and so on, where the operator skill level is also low. This is the commonly used method.
Yeah. Like this second part of my question, do we have the machine-to-machine talking facility available on this package, or can we do it?
Machine to machine machines can talk to other machines.
Yeah.
But in industry 4, what happens is you can actually, everything goes to a central, software. So let's say machine 1, which is process 1, and then you got machine 2, which is process 2. Let's say machine 1 is stopped, right? For whatever, no raw material or breakdown or whatever. And because machine 1 is stopped, you want to stop machine 2 also, because this is the upstream machine, and now there's no raw material for machine 2. So the moment the industry 4 software knows this, it detects that, and then it takes action on machine 2. It can do that. But machine to machine, there is no need. The whole point here is that there is a central.
There actually in the Intex 2019 only, I had seen in a couple of stalls that after the machining activity is done, there is a inspection station that is also automated. And whatever the results of inspection, the deviations in the dimension or measurement, those are communicated back to the machine, and the machine that does the setting changes automatically of its own. That kind of also it was in 2019. Yeah. Now I think it would have advanced a lot. Correct. In that
that is very much
possible. Does it need? My question was, if that is possible, because both the machines are CNC and they are automated machine. Our system, what we were talking with MSME group typically, where the number of manual machines is also quite large.
Right.
There, if you want to implement such kind of higher end kind of communication channels, do we need, first question is, can we do it? And
You
if
can do
yes,
that.
do we need kind of a high-end software for that or hardware for that?
So, like I said, as the firm grows and as you keep adding more automation, you can keep on adding these. Now, I'll give you at the extreme end. Let's say we've got one of our customers got an HPDC, high pressure die casting machine. There's a robot which comes and takes the part. Every part is over because it's hot. All loading and unloading is done by the robot. So,
Yeah.
robot comes, takes the part, and shows it to a vision inspection system, which is a CCD camera and so on.
Yeah.
So it shows it to the inspection system. The inspection system then says, okay, part rejected or accepted. If it is rejected, the robot will put it in the rejected bin. And accepted, it puts it in the accepted conveyor. What we do, now we are connected to the machine and the robot. So the moment there's a rejection on the robot, we know, and we automatically take that rejection and put it here. Things like that. And if the rejections are too high, if the frequency becomes very high, then we send out a alarm on the mobile phone. And the rejections may be very high because maybe there's a problem with the temperature, the furnace temperature or whatever it is. So they'll all be interconnected.
Right. Okay.
And one more question, Mr. Ramesh Shahir asked, how much lean manufacturing helps in industry helps to industry to 4.0? Okay, I'm assuming that the question means that what is the connection between lean manufacturing and industry 4.0?
Yeah.
So lean is just it. Lean basically is a philosophy of reducing waste, doing more with less, right? So that is lean. I need to reduce waste. Lean, in fact, it's all about waste only, reduction of waste. And what is waste? Waste is downtime, waste is rejections, waste is unnecessary. There are things outside the machine, unnecessary motions, and then there's an eighth waste now, which is the using an operator who's more skilled to do a lower skilled job. Correct. This is also waste. I'm paying somebody 40,000 rupees and I'm making him do the job of a 20,000 rupee operator or 30,000. That's a waste. So all these wastes, lean is about reducing these wastes, and you can reduce waste only by getting data on the waste. How much is my downtime waste, and what are the causes of this? I mean, what are the individual reasons for the downtime waste? Setup is so much. So out of 24 hours, my setup time was so much. The inspection time was so much. No raw material was so much. Machine breakdown was so much. Power shutdown was so much. I get all this data. Unless I have all this data, I cannot take action. And unless I can take action on this, I can't do lean. Right? So that is one thing. Or next would be rejections, rework. So all these wastes, you have to have data. So industry 4.0 is enabling lean, right? It is helping you to actually implement lean. That's what industry 4 does.
Yeah. I think it was a great session, very informative, and the audience now, and of course the people who will be seeing this again and again, who are benefited a large about having the basic concepts clear about industry 4.0 and their ability or the focus on that particular data management system, how it can be helping to ultimately improving their bottom lines. So I thank you, sir, for giving time to our audience and sharing a very valuable notes on overall effectiveness of the industry. Thanks a lot.
Thank you, and thank you all for listening to me for the past 1 hour. Have a lovely Sunday.
Yeah, thanks a lot.